Our eminent speaker, Mr. Joseph Francis, is Systems Assurance Engineer Infrastructure and Place Transport for NSW, is a risk practitioner who has spent over the last 8 years in the delivery of rail infrastructure projects and is currently based in Sydney, working in the public sector with Transport for New South Wales, TFNSW, and is passionate about intermodal transportation and environmentally sustainable solutions. A very warm welcome to you, sir.
First of all, I'm very excited to be part of the Rail Expo 2021. And I say my thank you firstly to the organizers. And I feel so privileged to be part of this expo and to talk to you in front of this avenue. So first of all, what we are going to discuss today is the system safety in design. It should be a straightforward topic, and a bit of background about myself. I'm Joseph Francis, and I'm the systems assurance engineer working with Transport for New South Wales in Sydney. To give you a bit of background about myself, I've got overall 8 years of experience in the rail industry, and I predominantly worked on the North American projects at my early career stage, and then I moved on to the Oceania. And now I'm in Australia working with the Transport for New South Wales on the regional rail project, which is the delivery of 29 new trains, the integrated maintenance facility, and the training simulator. Okay, let's start with our topic for today, which is the system safety in design. So these are the contents that we'll be going through. So we'll be talking about what is the systems and system lifecycle, some of the basics, and we'll go through the risk assessment process and how to identify the hazards and the hazard controls and do what is reasonably practicable thing to do. And we also see an example in the end about how we do a quantitative risk assessment and how we argue that it's a reasonably practicable thing to do in the design space. And so there we go. So the first question is, what is a system that we are talking about in this context? I guess it's really important that we understand that what is a system. And I've taken this from one of the textbooks, so I'm gonna read that out. So the definition says a system is an integrated assembly or combination of interrelated components or subsystems working towards a defined common objective. So it's a combination of different subsystems that will constitute to be a system. So this is a train called as the Waratah Series 2 trains, which runs in the Sydney network. And I call it as one of my trains because I extensively worked on this one part of the project. And so this train is parked at a station. So let's see what are some of the subsystems here that we are looking at, which constitutes as a system. So we can see at the train is stopped at a station, and there are some tracks which are underlying, which you obviously can't see on the photo. And there is obviously the signaling systems, and there will be the driver interfaces and the human factors elements to it. And there are obviously the other bits and pieces like the overhead wires and things like that, which all constitutes to a system. To make a system, so these are all the subsystems which involves. So let's go to the systems life cycle. So I believe that this diagram will be very familiar to many of us, and it's a diagram taken from the EN 50126 standard, and which says about the project life cycle when the project goes to the demand and the need when the project is conceptualized, and then it goes to the planning phase, and then it goes to the acquiring phase where a lot of designing and the construction activities will go on. And once it's been commissioned, then it will go to the operator to operate and maintain it, and then it goes to the disposal or the retirement. So when we talk about the topic of system safety and design, we'll be particularly interested in the first phase of the project, which is the mainly the planning and the acquiring stage, where a majority of the design works will be happening. So that will be the phase where the best opportunity that one will get for any of the improvement to inherit the practice of safety in design. Otherwise, the costs are going to shoot up if we do the system, the safe design after the construction or once the project is being commissioned. So we talk about a lot of opportunity in the initial phase when the cost will be very low, versus there will be opportunity in the design to incorporate any of the hazard controls in there as well. So let's go on to the next slide, and we'll see the overview of the system safety. So the system safety, so how do we ensure that the system is safe? It's an interesting question, isn't it? So it's a systematic, a documented approach to system safety and programs to identify the hazards and the risks and how we can control them. So when we have a risk, what we do first is we do a risk assessment. On the picture on the slide, what you see is the famous Blue Mountains of Sydney. So it's a rope walking, and there are obviously a lot of risks involved with it. And so let's come into the rail context and see what are the steps in a risk assessment. So the first step of that is identifying the hazards, and the next will be the controls. What are the controls that can be implemented to mitigate the hazards? And the third important step, which often is a debated topic, and to see what is reasonably practicable thing to do to mitigate the hazard. And final stage is documenting that so that we have an evidence of every activity that we are undertaking. So let's go on to the first steps on how we identify the hazards. So the hazards can be identified in a number of ways, and the most important way is by engaging the stakeholder of that particular topic. So for example, the stakeholder can be the operator, they can be the human factors specialists, or they can be the end users, wide variety of them. Identifying the stakeholder is the important steps. And we can also go through the database and the repository to find out if there are any of the existing hazards which are in place. And obviously the user engagement, like if you're building, if you're delivering a rail project, obviously there's going to be a mock-up of that in majority of the cases, and that's a good opportunity to establish the user requirements and the community impacts, and see if there are any potential hazards identified by that engagement. And obviously there are standards and guidelines which are available, and it's a good practice to look at any of the standards and to verify that if we meet the standards, and see any of the hazards are controlled, effectively controlled. And it's also a good practice to look into the previous example projects and see how they have implemented the hazard controls, or how they have the mitigated risks. So the first step is a tick. So we have identified the hazards. And now we go to the identifying hazard controls. And what are the practical approaches that we can take? So this would be a familiar diagram on the describing about the hierarchy of controls. As we can see on the bottom of the cone, there are the least effective controls like the administrative controls, and then it goes to the engineering controls, which are a better version to control it in an engineering way. And then the most effective way will be to eliminate the hazard if possible, and so that the hazards will not happen at all. So now we go to the third step of the risk assessment, which is doing what is a reasonably practicable thing. So what is a reasonably practicable thing? So the definition says that which is or was at a particular time reasonably able to be done in relation to ensuring health and safety, taking into account and weighing up all the relevant matters, which includes the likelihood of the hazards or if there are any risk concerned, and the degree of harm or the severity that might result from the hazard or the risk. So the likelihood and the severity that would define the risk, and what the person knows or the duty holder's responsibility about the situation, and in terms of the hazard or the risk or the ways of eliminating, or if it's not possible to eliminate the risk, what are the possible options to minimize the risk. And next is to check the availability and suitability of ways to eliminate the risk. And the last one is to see that if the cost is grossly disproportionate to the risk. So the cost is not just disproportionate to the risk. The gross it is grossly disproportionate to the risk. So when we are talking about the gross disproportionality, so we have to balance in the favor of safety always. So when we have a cost and the safety benefit, a gross disproportionality factor will be added on top of the benefit cost, which we are going to see in the coming slides. So it's when we are making a decision for in favor of safety, we have to make we have to balance towards the left hand side. We have to balance it towards the safety, not worrying about the cost. And now we go to the quantitative risk assessment, or a systematic way of doing the risk assessment. So it's an interesting topic where people get many of them get confused. So what is the risk cost? The risk cost is technically the statistical likelihood multiplied by the likely severity, which in other words, it's the likelihood versus the cost of the injury or death of a person in terms of the WHS perspective. So what is the value of statistical life? So I have to put a disclaimer here. What I'm presenting here is purely in the Australian context. The amount of the value that has been put for a life is 4.9 million in Australia. That would obviously vary from based on the socioeconomic performance or the life expectancy or the GDP of a particular country. So 4.9 million is generally considered as acceptable in Australia. And so the cost of the injury is the 4.9 million. And from where did I get this figure? So it's the figure which I'm quoting is from the Department of Prime Minister and Cabinet's guidance note, which is published in 2019 in the best practice regulation. And so if it's one fatality, it's 4.9 million, and 10 major injuries. If there was a real accident and if there are 10 major injuries, it's considered as one fatality. So which then we have to equate the 4.9 million to divided by the number of injuries. And if it's a 200 minor injuries are considered as one fatality. So we'll see details about that in the coming slides. So we talked about the gross disproportionality factor here, which is purely based on the user type or the likelihood or the consequence. For it's a thumb rule that for the general public, it's always a factor of 10 is being used, and if it's a worker, I mean like a trained worker, or it's always a factor of 3 it's being used. So the interesting topic will be what is then a reasonably a practicable thing to do. So if the control cost, so we have identified a control in the risk assessment, and if the control cost is less than the risk cost and multiplied by the gross disproportionate, so it's then obvious that we have to implement control. So if it's the cost is way higher than the gross disproportionality factor and the risk cost, then it would become a thing that it's not reasonably practicable thing. So it's important that we do the right thing in the design so that the controls are in place. So now we see an example on how this strategy or how these concepts can be implemented in a risk assessment. So on the picture that you see is one of the Sydney Trains fleet. It's called as the Tangara fleet. And so the hazard that we are looking at here is the passenger being trapped by a door when boarding or disembarking the train. So it's a hypothetical situation that I'm talking about. There are effective controls in place, but to give an example, I'm just taking a hypothetical example in this scenario. So first we list out what are the hazards. The passenger has been trapped in the door. That's obviously the hazard, and the cause for this for that would be the door system is not synchronized with the passenger movements. There may not be adequate controls in place, maybe an engineering control or some administrative control in place. And consequence of that would be obviously the major injuries. If someone is stuck between the doors, it's pretty obvious that they'll have some level of major injuries. And let's also assume that the life of this asset that we are going to design is for 30 years. And let's go some details to the calculation. And let's see what are the control costs here. And let's see what are the controls that we can put in place. So obviously, the controls that we can put in place will be to add in an obstruction detection, such as some sensors or some software upgrades on the door system, such that the door control unit is being alerted when a passenger is being obstructed, or if there are any obstruction, the doors doesn't close. That could be one of the controls. And let's see what would be the cost for that control. So I'm assuming that the cost for implementing that on the fleet will be 2 million at the design phase. And for the 30-year life cycle, that will be roughly around 0.5 million. So the total control cost is now 2.5 million. And let's see what is going to be the benefit cost or the safety benefit cost that we are going to achieve. So the consequence of this hazard is going to be that we'll end up in definitely a major injury. And so the major injury for one major injury, the value of statistical life divided by 10, that would be give for 90,000. Because for one fatality is 4.9 million, for one major injury that is divided by 10 multiplied by 4.9 million, because we are assuming that 10 major fatalities, the 10 major injuries is one fatality and 200 minor injuries will also be one fatality. In this case, we are assuming that there will be one major injury at one for one instance, and the likelihood of the event in 30 years, let's say it's 95%. We can't assume that it's 100%, but let's make it very conservative figure that 95% of the time when the train runs in the network, it's likely that this event could occur. And the risk cost now is the likelihood into the severity, which is 0.95 into 490,000. So we get the 465,000 as the risk cost. So it's definitely impacting the public. So as we described in the previous slides, that the situation needs to be analyzed in the favor of safety. So we are assuming a factor of 10 because it's impacting the public. So the safety benefit cost that we are receiving is 4.65 million. So 4.65 million against the control cost. It's pretty obvious that we have to implement the control. We have to have some obstruction detection in place, because no way we can argue that the cost is grossly disproportionate, and it's a reasonably practicable thing to do. So that is the example that we have we have seen how we can use the risk assessment in a quantitative risk assessment in a real life scenario. And with that, we have ticked on 3 boxes. So we have identified the hazards. So we have identified what are the controls, and we now know what is the reasonably practicable thing to do. And the final step is document it. So these are the risk assessment, or in terms of the reasonably practicable test, which is called as SAFAP in Australian context, is a legal requirement. In UK, it is called as ALAP, which is almost the close to the SAFAP concept anyways. So it's a legal legal requirement. So if we end up in an accident, and if we have not designed appropriately in a safe manner, it's a good chance that we end up in court. And if we have not documented this process, it's a huge risk that one is going to take as a duty holder or as a designer. It's most important that the record keeping and the documentation is proper. So it has to be very clearly demonstrated at that point of time when we do our risk assessment, that the hazards or the controls which we have mitigated or we have demonstrated that in many cases that we could only minimize our risk because the cost is disproportionate, which would be the right thing to do at the right point of time. But we have to do all of that, and we have to keep the evidence of the hazards list, the hierarchy of controls, and what are the controls that's been analyzed, and how we came to a conclusion that what was the reasonably practicable thing to do. And with that, we come to a conclusion. And on the picture that you see again is a new intercity fleet, which is being currently rolled over in the network, in the Sydney network, which are the brand new NIF fleet. So with that, we come to an end of this session. And if you have any questions, I'm more than happy to answer all your queries. And I've put my LinkedIn the website as well, the address as well. So if you guys want to have a chat, or if you have any questions, feel free to reach out. Or if there is any other medium to ask questions in the Rail Expo 2021 forum, I'm more than happy to have that as well. I'm more than happy to meet you all in person, or I mean, like to have a one-on-one discussion. It may not be possible in person, anyways, in this the COVID scenario. But I'm happy to answer all your questions. And thanks for listening. And thanks again for the Rail Expo team for organizing this